Hey everybody, how's it going? Awesome, everybody having a good ZK Accelerate? Yeah, okay, cool. I'm Lance Davis. I'm a software engineer at Giza, where we do verifiable machine learning in Cairo. I am here with Mamy Ratsimbazafy, Misha Komarov, and Diego Kingston. We'll be talking about future frontiers in ZK research. So if you're curious about future proving systems, just in general, the future of the ZK industry, you're at the right panel. I wanted to start by asking you all just the classic ZK question about snarks versus starks. What is your preference? What does your team use? And is there anything that you would say is a clear, definitive winner?
Okay, I'll start then. My experience was I started being a snark guy, then I switched to starks. The thing is, I think that to make the distinction right now doesn't make really any sense. Sure. It's more like, perhaps, as we were talking here, a Twitter fight. But I think that, at least for beginners, starks is easier to learn because you have like less things. You only have like finite fields, hashing, and you don't have to get into some like gory details related to elliptic curves, pairings, extensions. So really, that's why I like perhaps a little bit more starks, but just personal preference.
For sure.
Okay, well, here we go. It's like what I'm saying is that there's no difference between them, in fact, because both of those are just different combinations of the same components. I mean, like, let's say it this way. For example, like on our side, we have, I don't know, Blanky share fertilization over hash-based commitment scheme. What is it? What is it? Like a stark, a snark, what the hell is this? So that's the first thing. Second thing, let's say this way. I mean, it's like Stark's naming was made up just to highlight that there's just a switch in the commitment scheme and that's it. So that's, like a pure marketing effort. It worked out great. I mean, people actually use it as a term, but in fact, it's pure marketing effort. So no difference. I mean, it's just a combination of different techniques. So there are weird mixers. There are weird mixes of that, and we use one of such mixes. So it's like, what's the difference?
For sure, for sure. So it's like it depends on the types of tools that you want to use to prove.
Yeah, it depends on what you want to do. It depends on the answer to the question why.
Yeah, got you. Maybe?
So for me, obviously, snarks win, because if you want to prove on the EVM, you have to use snarks, because there is no other alternatives. You have growth 16 and proof composition if you use starks anyway. Well, joking. Actually, at Taiko, we have a multi-proof approach. So we invested for 2 years into the Hello 2 KZG by the PSC team at the Ethereum Foundation. And more recently, we also are exploring ZKVM. So from Rusty Powder Nil Foundation, also because writing circuits for snarks is very painful.
For sure. So in terms of the development of ZK, would you all say that most of it takes place in academia or in industry?
Well, I think it takes place in both places.
For sure.
Of course, you have like different perhaps incentives or goals in academia and in industry. Ideally, what you would have is like a joint effort between academia and industry. Yeah. Sometimes in academia, you have like more freedom to explore certain paths that perhaps when you are in a company, you don't have that much freedom. But then, of course, you can get those cool ideas. And if you see they work, try them. So really, we've seen like many people also, Starks, Eli comes from university. So it's just like, it goes both ways, I think.
I mean, the academia, if you want to fuck around, then of course the academia is your choice.
For sure.
It's like, and find out something, right?
Yeah.
So if you want to do the actual product, just do the actual product. Why do you need academia? That's like the thing. So all the actual like, product used use cases, all the actual like product used like combinations of whatever, like proof system, whatever it is, all right? Were done, just for particular use case, for particular thing. It's like, that's, that's just what it is.
Makes sense.
So people always ask, what's the killer application of blockchain? And I'd say it's zero-knowledge cryptography research. Now, VC funds like Geometry, who are not with us today, they even have a cryptographer in residence, and that's also the same for Andresen, Horowitz, Paradigm, and other funds. But like Misha said, I think academia looks into the theoretical, but there are many, many engineering challenges that come up, and everything that we talked about at ZK Accelerate that relates to GPU, FPGA, parallelization, it's not, it's computer science, it's not cryptography research that's done in academia.
For sure. So as a follow-up to that, since we're all industry here, what is you all's approach, or at least I would say engineering approach, to developing new systems in ZK? I know that each one of you have had experience with this. What is more so the design approach and execution phase?
Well, I think that in industry, what you try is to fail fast.
Yes.
You want to see which ways can work, which ones don't. And then I think we also have something that, well, we implement and then we start iterating a lot. We also try to learn from other teams. Really, what I like, especially of this field, is that there are lots of open source developments. And so sometimes some project thinks of some cool idea, we have another, and maybe we can combine all those approaches. So really, that way we can build really nice solutions, and that's it.
For sure.
The approach always depends on the use case. It's like over the years we had, a bunch of different use cases, starting from, I don't know, inventing ZK bridges, or like, I don't know, going to whatever, all the, proof market stuff, ZK Oracle stuff, and different things. So in the end of the day, with placeholder, we resulted into, trying to make it as flexible as possible. It's like being possible to adjust it to a particular use case, which is like, right here on the table. So, I mean, just make it adjustable, I guess. I mean, that's what it is. Make it flexible enough.
Yeah.
I guess on our side, we have a researcher, and for the more prospective stuff, for example, recently it would be optimizing lookups, but compatible with KZG commitment. We send that to that researcher, then we have a team that will implement either proof of concept or something that has been researched, for example, by the Ephraim Foundation, and that we work closely with. The issue is that we have a go-to-market, we have a mainnet, and we cannot focus that much time on research, and it's very important, like as open source communities, Telegram channels, like Zero Knowledge Podcast, that we use to share ideas is very important. And if you've seen the rise of AI, it was also the same 7 to 8 years ago. You had many frameworks, Theano, TensorFlow, PyTorch, Chainer, MLIR, and everyone was talking to each other, and it went up very fast. And I see a similarity in ZK, is that competing companies are still talking, because I like that they think we need to grow the pie and not just grab everything and just keep in a small corner.
I like that answer.
Yeah, no, we like a lot your repo with all of the optimizations in fields. It's awesome because you know all the tricks. So thanks for the effort.
For sure. So what I'm getting here is that you need to fail fast, but then also the open source community is a really important aspect of it. In terms of somebody who is new to the space, doesn't really know much about the resources that are out there, for example, the podcast, the open source repositories, what advice would you give them for starting a new research and development project in ZK?
Oh.
I guess there are a couple of very good communities that aggregate a lot of info. So, for example, 0xPark has a lot of tutorials from zero to hero. You have the Moon Math manual by Leaf Authority. You have a course that was given at MIT by 0x Spark called ZKA IAP, which goes from the ground up. Risk Zero have those study club. At Taiko, we have the ZKA roller coaster to keep up with every updates every 2 weeks. We're agnostic. We talk about everyone. And Lambdaclass has also, well, there's Zero to Hero and an excellent community about ZK. So I think you need to get into one, and then you follow the breadcrumbs.
Yeah.
It's like on our side, we hosted and we still host like a series of, like workshop, explainers, everything. But I would say they are more related to, not, how to reinvent the wheel, but on how to, like expand the field. That's like, a little bit of an effort we do from our side to, help with this.
For sure.
Well, in my case, I didn't come from cryptography. I come from chemical engineering, so I had to learn all this stuff from the beginning. And really, I found that there were like very good resources like the ZKA MOOC. It was a little bit more academic, but at least from my studies and all that, maybe it was more familiar to me. You also have to find the resource that's right for you. Some people are more math-minded. They need to understand the math first. Some other people like coding and like reading code bases. So maybe you have to find which one is the right approach for you. Of course, the best idea would be to follow the different projects, because there you have different resources and also code. Because there is one thing that when you read a protocol, in the paper, it's one thing. When you implement it, it looks completely different. So going to the code base lets you figure out all those details, or at least the choices some people made to solve those problems.
For sure, great answers. So then when we go the opposite direction of companies or research institutions creating content, Taiko, Nil, and Lambdaclass all have wonderful content out. What is the typical production life cycle for great content, especially when it's very technical?
Well, right now we are doing several bootcamps. So I am in charge of the Sparkling Water Bootcamp, and I am super happy to have many of our interns here. And the idea is we try, as always, to iterate fast. We have like open discussions, try to be as clear as possible. Maybe we try to find also places where there is not so much information, because really, if we see a very good resource by somebody else, we just put it in our learning path and say, go read this, read that. And yeah, we try to play a lot. We are also teaching a course about cryptography at university. So really, what we want is also to get feedback, because we realize there are different profiles. There are people who like code, and there are people who like more math. And so you have to address both and try to generate resources that are adequate to each group, and try to also make them understand the math, because really in ZK, you need to understand at least the basic concepts.
Yeah.
Well, on our side, we don't see any point in spreading effort to, just educate for nothing. So once an educational content and something coming up from our side, or like, just happening from us, some workshop or like whatever, it's usually about something, some problem on the market we see which can be currently solved. So this could make absolute sense for the folks coming in with something like, okay, this is the actual thing which can actually be used, and we can even, if you come to us with, as after a workshop or something, we can tell you exactly whom to come to and what to do to get this used by somebody, like the actual product thing. So it takes a lot of fighting internally. Like, for example, with a proof system thing, with a proof system like on London workshop we did some time ago, Alisa did it. We basically targeted it to that point when we realized that people have considerations about, how performant the toolchain is, or like, can it handle something or not. So we're like, okay, well, this is how it works. And this it can handle, this it cannot handle. That's the thing. Or like there was an Oracle workshop. It's like we hosted a ZK Oracle workshop exactly when we saw that there was a market opportunity for those who come to this workshop to get such oracles built up for different products, for different protocols, and solve the actual problem with it. Yeah. So it's all about we kind of try to target when we see it makes sense for something.
Yeah, for sure.
So for content management, I think companies need to realize that it's a full-time job, and the skills to get into all of mathy detail and get those into a comprehensible wall are very rare. And usually the research takes a long while, so they have multiple streams at the same time, and they just take notes as news come from companies, from research, etc., and then they ask engineers, what do you think of that? Is there a future? And at one point, you have something good enough to create a content. And if it's not enough, you just go to the researcher and you pick their brain, you organize a Twitter space or a video, and then you do a summary, and you add everything all together.
Got you. Great answers. Just want to ask, in the perfect world of ZK, do we still use trusted setups?
Well, that's another dimension. But of course, really using trusted setups gives you some advantages because really you get smaller proof sizes. So maybe it's something that still you don't have like super powerful quantum computers, so maybe you can deal with it. And really, it offers like some advantages also in terms of the cost, of the verification cost. So maybe for the time being, we'll have to settle with trusted setups, even though we wouldn't like, at least in my case, to have a special setup and have to trust that it was done correctly. So that's a problem.
I'd say, do we use it depends on the use case again. It's like for some cases, the security assumptions are critical, and you cannot rely on trusted setup of whatever size. So you just cannot fuck around with some use cases. Okay, so it's like, for example, like with the placeholder securing like Lido thing, it's like you cannot just do anything with it. You get like as secure as possible. That's the thing. But in the same time, verification cost, let's be honest, is all that matters. Everything else is bullshit. So, I mean, you will not get proper verification cost on EVM until EVM changes for the absence of trusted setups. So once EVM changes good enough, I mean, we'll get a better cost, and, it makes no sense to use KCGY.
Yeah.
So on the EVM side, one of the most costly thing is the state. And the issue with stocks and everything that do not have trusted setup is that the state grow with the size of what you want to prove. So for blockchain use cases, I think trusted setup will still be needed. But then in the future, maybe if we reach a perfect world of ZK, it will be when you have quantum computers and you won't be able to use pairings on elliptic curve at least, and you'll be forced to use stocks. Now, if we get pairings on lattices, that might be solving some of the problems that we have regarding quantum computers, for example.
For sure. So just wanted to ask some individual questions. For Mamy, I wanted to ask you about trustless bridging on Taiko using ZK. What do you all do now?
So at the moment for bridging, we don't do anything specific cross-chain, but we have a partner, Polyhedra. They just received a grant last week, and the product is ZK Bridge and ZK Lite client, and they do that with a fast finality. And so for now we rely on partners. We need to pick our fights.
For sure. And then Misha, what about placeholder and the ZK LLVM?
So, I mean, it's like, what about it?
Yeah,
I mean,
just chill it.
Okay, whatever. So basically, it's So basically what it is, it's a proof system designed for procedural generation of circuits. It's like, tightly coupled with the circuit compiler. The circuit compiler has been used like for, different use cases, like, starting with ZKA VMs, like for ZK sharding we spoke about like recently, or like, for cases like, some ZK oracles, some cases for ZK bridging, some ZKML use cases. So, it's a Planck-ish arithmetization proof system with IVC coming on. Default commitment scheme in there is like, LPC, list polynomial commitment, modification of Fry, okay? So there's a way to switch the commitment scheme. So that's like the thing.
Really cool, cool. And Diego, want to ask you about recursive starts, particularly those that use multiple proving systems, like using Growth 16 to verify a recursive start.
Yeah, the idea is that in Starks you can use recursive proving, like to batch several proofs and then distribute the cost of the final verification among all the different programs that you proved. So the thing is, Starks have a logarithmic proof size, which is sometimes not convenient, and besides in the EVM, well, you have to verify it using pairings, so you have to change the proof system. Of course, in that case, since Starks has a different native field, you are forced to emulate the field, which adds some overhead. Of course, then the cost is in the prover, not in the verification. And really, that way you can get like a very succinct proof. So it is interesting. It is being used by several companies. For example, the ZK EVM by Polygon has one final step where they use Growth 16. Of course, by doing that, you also lose the post-quantum security, but nevertheless, Ethereum relies on elliptic curves, so we would have to change Ethereum first.
Interesting. Thank you all. Wanted to ask if there are any questions in the crowd. All right. I have an application question if there are none. Want to ask you all about zero-knowledge multi-party computation. What do you where?
Hello.
Yes.
I just wanted to know, like, what do you guys think about folding schemes and all of the research that is being done on folding schemes?
So one of the paper of 2023 was revisiting Nova on the cycle of curves. And that highlighted an issue in the, not in the research of folding, but just that when Microsoft did Nova, they created security proof on normal curves, and then for efficiency, they implemented this on the pasta curves. And then, it was broken. The fix was quite easy, but it means even though there are a lot of interest in Nova, Supernova, Hypernova, Protostar, Protogalaxy, I don't know what else, we need to move slowly, but also fast, because we need to fail fast to prove if it works or not. Otherwise, everyone will go to Starks, I'd say. But there is interest, at least at Taiko, and Misha said that he has interest in IVC, and he will release soon. So.
Yeah, and also the people at Starks were trying to see whether we can use some of the cool ideas from folding schemes. Of course, perhaps what we lack is comprehensive benchmark. We still have to discuss that and try to get to more realistic numbers. But again, as Misha said, it also depends on the use case. So we have to see which one is the best option for your case. And luckily, I think we are all moving into a multi-prover. For example, we at Lambdaworks have both a Planck prover, a Stark prover. So we want to give the user the option to choose which one is best for him.
I would say regarding interest in Nova-like IVC constructions from our side, It's like, well, funny thing is that the paper you mentioned, folks are doing this over past the curves. We did this a little bit earlier in terms of just, never published. But anyway, it's like, and we faced the same issue you mentioned. So it's like, yeah, I mean, it's like, it's the thing. But anyway, it's like, doesn't matter. It's like, well, Alisa will give a talk about some of our efforts in this field, I guess, like, I don't know, 10 minutes or something. So yeah, just. That's going to be the answer.
For sure. Awesome. Any more questions from the audience? Oh, we have one more back there.
Okay, so I kind of wonder what's your guys' opinion on Lasso and Jote, and which is a like newly proposed ZKA VM architecture.
Yeah.
It's not really a ZKVM architecture. It's more like the approach of proving the lookup table structure instead of proving the actual execution. So it's like, just one more level of indirection. So that's basically like what it is. And I mean, looking into it, haven't done it yet. Just, taking a look at it.
So that's all the time that we have. Unfortunately. But thank you all so much for coming to the panel. Thank you to our panelists, and hope you all have a great rest of the conference.